take a look at some comparison and logical operators. Over here, we have some comparison operators, and over here we have some logical ones. So let's start on this side. So first we have less than. This is saying, well, if something is less than another, just like in math. Less than or equal to. Again, is something less than or equal to something? Right? Greater than. Same thing. Again, is something greater than another? Is 2 greater than 1? Yes, it is. Is 2 less than 1? No, it's not. Is 2 less than or equal to 1? No. Right? And then we have the same thing with greater than or equal to. So now let's talk about equal to. As you can see, there is 2 equal signs. This is because the symbol that is just one equal sign is taken up by when you assign values to a variable. So instead, there has to be 2. So you have to remember that. It has to be 2 equal signs. Then we have not equal to. And it has an exclamation mark instead of one of the equal signs. Now, let's talk about the logical operators. So, these include and, or, and not. Obviously, there are a couple more that are kind of like this, but these are the only ones that we will need, and they're pretty widely used. So, if you want to say, if this is true or this is true, meaning that it will reply true if at least one of the conditions is true, then you do 2 vertical lines. Then for and, if you want to say if this and this is true, meaning that both statements or both conditions have to be true for the and to return true, you do 2 of the and symbols. And then we have the not. Basically, if you want to say something not, like if this and this are equal to this, right? If you want to do if this is equal to this and this is equal to this, if you want to return false, you want to kind of reverse it, then you can use not. So as you can see, as from the comparison operators, there's not equal to. So instead of doing that, you can just do the equal sign, and then you can just do the not sign. And these two are the exact same thing. It's just that not equal to is just a little bit easier to write. Alright, so let's look at some examples of comparison and logical operators. So, in this statement right here, both of them are being used. So you've defined the height in feet over here, and then you have an if statement. So, what the if statement is saying is, if your height is greater than or equal to 4.8 feet, and it's less than or equal to 5.7, then it will print average height, letting you know that you are average height. This makes sense because if you are greater or equal to 4.8, meaning 4.8 is bottom line, right? That is the lowest you can be to pass, right? And you you have to be less than or equal to 5.7, meaning that if you're 6 feet tall, that's like, wow, that's really tall. You haven't made the cut. So it will return false because of the and sign right here. So this is an example of comparison and logical operators. Alright, let's go back to expression evaluation for some time. So, in this case, we are defining A and B as integers that have different values. And in here, we are printing out, remember, system.out.println prints out, this statement, A equal B. As we learned earlier, equal is for equal to. And, well, does 1 equal 3? No, it does not equal 3. So, since this expression is false, it will print false. So, notice that both of these are integers, yet the output of the expression is not a int. This is actually a Boolean. Alright, so let's start talking errors. There are two major kinds of errors that you can get in coding. There's the syntax error, and then there's the semantic error. So let's talk about the syntax error first. Basically, the syntax error is the equivalent of grammar. It's like if you miss something, like a period, or you haven't capitalized something, where whatever you've written is just simply wrong, and the computer can't understand what you're saying because you haven't followed the grammar. For example, here, you haven't closed the line out, so the computer doesn't really know what to do. You've missed the semicolon that's supposed to be at the end of that line. Now let's talk semantic. When you have a semantic error, basically it means it doesn't really make sense. And in a way, it's confusing the computer. Obviously, a computer can't be confused. It doesn't have emotions. It's not that smart. But just think about it that way for now. For example, if you make int I equal 1, you define int m, and then you try making m t. And the computer's confused. It's like, well, where's t? There's no t here, right? There's an I don't know, like there's no t. Well, what's going to happen here, right? It just doesn't make sense. So those are the different errors that you may find. And you just have to read it carefully and figure out what has gone wrong. Now let's take a look at some conditional statements. So these are the kind of things you would use equal, and greater than, and less than equal to. If you want to check, hey, is this greater than or equal to this, or something like that. So let's look at a kind of flowchart of what it does. So it enters the loop and it starts with the condition. Is it raining outside? Right? Is it raining outside today? This is a real world example that you might have actually came across before. So, if it is raining outside, then you gotta wear a jacket. And you just gotta continue with the rest of your day. But what if it's not raining outside? Well, then you don't really need to do nothing. Nada. There's nothing to do, right? You just carry on, right? No jacket. So you can do this in programming. You don't need to write the else statement if you're not going to use it. And it just continues into the rest of the program. So, when we were finding out which utensil to bring, instead of being "it's raining outside," it was "is it an orange?" Right? Is it the lovely orange? Sorry for my drawing skills. It's a little hard drawing here, but let's just say this is an orange. Is it an orange? Right? And if it is, right, we're gonna bring a fork so that we can eat the individual pieces, and otherwise we're just gonna bring a knife, right? Whatever it is. In the case earlier, it was an apple, so we went to the knife section, right? So we got a knife, and then we continued with the rest of our day. So let's get you introduced to the programming conditional. This is called the if-else, because, well, in conditionals you're asking if this is true, else this is true. But also, you also have the else if, which is if this is true, otherwise we can check if this is true, then else if all else fails, we'll do this. So let's look at the flow of the thing. In the if, we have a condition that we're checking. If this is true, we will do the action, and then we'll skip over all of this and continue with the program. Because, well, in this condition, if one of these conditions is true, we don't need to check the other ones, and we don't want to do any of the other ones, because that's not the point of a conditional. Now let's look at the else if. Again, this has a condition, and it goes through an action if that is true. Note that it will only come to this if the if is false, right? Otherwise, it's just going to skip over everything. And in this case, if the else is true, it's just going to if the else if is true, it's going to skip over the else and continue with the program. Now, let's take a look at the else. And like I said earlier, this doesn't need to be here. For example, if you don't even need to do an action, all of this is not needed. It's not mandatory, right? But it's there because if all else fails, if none of the conditions are right, if you want to do something, then you can use the else. Note, if you want to check if this is true, and if you want to do something there, and if it's, well, not, then you want to do something else, then instead of doing an if to check it, and doing an else if to check if it's false, you can just do an if to check if it's true, and then an else. Because if it's false, then it's going to go through the else. So you don't have to write down the condition. Conditionals are used for lots and lots of things, like decision making and just plain telling you things. Like, if you want to know if some huge number is even or odd, or if it's prime or if it's not, you can use if-elses. And they're very, very widely used and super duper useful. Let's look at some real code, including if, else if, and else. So in this case, we are checking for the season. So in this case, there is the third season, and we want to know what is the third season. So it goes to the first line, and is season equal to 1? No. So it goes to this line. Is season equal to 2? No. So it goes to this line. Now, season does equal 3, right? So then it goes to this line over here. And this prints out summer in the terminal. Right? So, this else statement isn't really needed in this case, but if we would have the season to be 4, then of course it would go and print fall. Note that you don't have to always have the else. It's not mandatory to write it if you don't need it. Now, as you can see here with the if-else and then the else-if, the else-if allows you to add more conditions so you can check multiple things. Now let's start looking at loops. As you can see here, there are 2 different kinds of loops. The first one is that it does something n times. You can specify this, right? But it will do it n times. Then you have to do something while this is true. This one is called a for loop. And this, as is in the name, is called a while loop. So let's look at some examples. As we saw earlier when we were going through our house to get those utensils, we could use a for loop to say go forward 5 steps, meaning that you would keep on repeating that steps using a loop. In one iteration, you would go 1 step, next one, go another step, another step, another step, until you got to that place and finished the loop after 5 steps, and 5 steps exactly, nothing more, nothing less. So let's look at what happened in the while loop. Alright, so just like before, when we're at a point in the house, let's say this little circle's us, and this over here is a door. We could just keep on walking forward until we were at the door. So, what this would do is, it would go 1 step, it would go a step, and then it would check if we're at the door yet, if we're at the door. If not, we would go again. And keep on going until we reach the door, and then the loop would end. These 2 kinds of loops help us be able to write less code while still doing the same thing. For example, in a for loop, instead of writing go 1 step, then 1 step, and 1 step, and 1 step, and write that 5 times, all we could do is put it in a loop and it would be much shorter code. Same thing with the while loop. We don't have to write go 1 step forward, then check with an if statement, then go 1 step forward and hope you've put that enough times for you to reach the door. No, we can just use the for loop and the while loop, making it much, much easier. Now let's take a look at the while loop and the while loop alone. Remember, this is the one that we used to keep on doing something until some condition was not met. So let's see how this is done in coding. First, from the start of the loop, it checks a condition. And if this condition is false, it will just end the loop and continue with the rest of the program. If not, it will go down here and do whatever task you have set for it to do. After the task is done, it will go back to the condition. Check the condition again. If it's true, go to the task. If it's false, just end the loop. And this will keep on happening until the condition is not met. So, with this, you can also make an infinite loop. To do this, you don't really need to have a condition. All you can do is put true here because, well, it's just always going to be true, so you're going to keep on doing the task over and over and over and over and over and over and over again. And this can actually be useful in some cases. Alright, let's take a look at the flow of a for loop. As you can see, it is pretty similar to the while loop, as it has a condition, and if it outputs false, it ends it, and then you also have a task. So mind you, you can do the same things with either loop. It's just that for certain examples, like for doing something until this is true, while is just an easier way to do things. So in a for loop, you have a couple things. You have an initial statement, you have a Boolean expression, and you have an incremental statement. So basically, you have to keep track of how long the for loop's been going for. Later, when I show you in code, you will see this much more clearly. But you have to initialize a variable, like int I, which is the convention, and then here in the condition, you have a Boolean expression, and then over here you have an incremental statement. So you go into the condition. If it's true, then you do the task. Then you have some sort of incremental statement, like I equals I plus 1. Then you go back to the condition, do the task, do the incremental statement, and keep on doing that until the condition is false and it will end. So, if you make the condition for I has to be less than some number, and you keep on incrementing it, then if you calculate it right, you can make the loop go a certain amount of times. Again, you can also make this an infinite loop. Let's say that you make this statement, you can make the condition anything. Let's say you start out int I to be 0, and in the condition you do I is less than 10, and then in the incremental statement, you don't increment it at all. You just do I equals I plus 0. Then this will just go forever and ever and ever until somehow you make it exit the loop. So let's look at each of the loops side by side. And yes, both of these are doing something n times. In this case, the n equals 10, and it will print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 10 different things. So, let's look at the differences. When we first create the variable to keep track of everything, in the initial statement, they are at different places in each of the loops. In the while loop, you have to create it outside of the loop, because as we saw earlier, there is no thing like that for the while loop. But in the for loop, it's made for this, so it's inside of the if statement's brackets. So then we have the condition, which is in one of the integral parts of each of them. And they are both inside of the brackets. These are keeping track that when I has to be less than 10 for it to do whatever is inside here. Now, both of them print I and keep on printing it until I is not less than 10. And then they both have the incremental statement. So in the for loop, it makes the initial statement, it checks this, it does whatever's inside of here, and then it goes here and does the incremental statement. But in the while loop, while it's doing whatever is inside the loop, it just gets to the I++. So, as you can see here, the for loop is a bit more cleaned up and it takes a few less lines. This is why, for this case, the for loop is just a better choice to use. And the while loop is a good thing when you want to check, when you want to do something until something is not true, or until something is true, or until something happens, right? So, as you can see here, they are not so different, but you can choose whichever you like to do different tasks. Mostly for this kind of stuff, for loops are better fit, but really it's just your choice. This is a practice of conditions. So in this you have to make something that will tell if x is even or an odd. But this should work for whatever x is. Then, after that, I have a little challenge question. Can you do this using at least one if statement that doesn't have an else? A hint to help you with that is to use a Boolean. Pause here and then I will show you the answer. Here is the answer. Now let me show you the answer for the one that uses a Boolean. As you can see, these things do the exact same thing. They're just implemented a little differently. Let me point something out that, as you can see, it just says is even, not equal to. Well, this will still work if you do equal to true. But if you just put something inside of the brackets, then it just implies this. It's a little shortcut, so instead of having to write equal true, you can just write is even, which, if is even is true, it will go into statement and print even. This is a practice of if, else, if, else. Check if this number a is between 5 and 10. If it is, print that it is. Pause here, and after a few seconds, I will give you the answer. Here is the answer. As you can see, there are two ways of doing this. One with if, else, else, and the other one with an if and an and. Here we are practicing the for and the while loop. Do each of these exercises using a for and a while loop. Pause it here and I will give you the answer after a couple of seconds. Here is the answer for the first prompt. Here is method 2 for the second prompt, using the for and the while loop. And here is method 1. As you can see, you can do it differently. They're just using some different things. Now let's talk about infinite loops. All you have to do here is make an infinite loop, and In each iteration, print hello infinite. A hint is to use a while loop. This just makes it a little easier. Pause the video here, and after a few seconds, I will give you the answer. So, what is going on here? As you can see, instead of having a condition, like we used to, it's just true. This is because instead of the while loop evaluating if the statement is true or false, it's true. It's given that it is true. So every single time it goes into the while loop and it just shows true. Then inside of the loop, we are simply writing hello infinite. So this is how you run it, and let's see what happens. After the program starts running and printing, you can see a red box off to the side. This is to quit the program because it won't naturally stop as it's a forever loop.